D-Tutors, bringing learning to your doorstep.
Looking at work, energy, and power. Work, energy, and power. The first point, we need to look at work, energy, and power. Now, from the first concept, when we talk about or when we discuss about work, we can say that work is said to be done when a force moves a body through a certain distance in the direction of force. Now, when we talk about force, what makes up force work is FD, which is force distance. Now, work generally is a scalar quantity because it has magnitude, which is size, and as well as a preferred direction. Now, when we say work, we talk about two things about work. We said work can be horizontal and it can also be vertical when it comes to components. Now, in a real sense, when we are talking about work, we are talking about a force acting on a particular body with respect to what? Its perpendicular distance. Now, for instance, if it is work on horizontal components, we can say FD cos theta. But when we say work in vertical components, we can say FD sin theta. So when we talk about work generally, we can say work is when a body is acting on a force, which is F, and likewise its perpendicular distance with respect of that same force. Now we go to the next concept, which is energy. Energy in a real sense means is the ability or capacity to perform work, that is, at which work is done, and that is energy. And this energy is subdivided into two. We have the kinetic energy and the potential energy, which is under mechanical energy. Now, kinetic energy and potential energy, which is under mechanical energy, we can say kinetic energy, it is energy in motion, which is in movement. Or let's use motion for instance. Then potential energy says energy at rest. So whenever energy is at rest, we say it exhibits potential energy. So when we say energy in motion, which is acting in motion, we can say it is what? Kinetic energy. So kinetic energy is stated that whenever a body is in motion, we can say it is kinetic energy. When a body is at rest, a body is not moving, a body is stationary or motionless, we can say such body exhibits what we call potential energy. So when we talk about energy, we talk about what we call the forms or kinds of energy. And the first one we have the chemical energy, we have heat energy, we have sound energy, we have light energy, we have electrical energy, and so on and so forth. So all of them mix up what we call the forms or kinds of energy. So when we are dealing with energy, we discuss about what energy is all about, the types of energy which is generated or gotten from mechanical energy, and we also have the forms or the kinds of energy. That is how energy is being what? Generated. Now, lastly, we have power. When we talk about power, we talk about the rate of doing work. Now, when we say power is the rate of doing work, we are talking about what makes up that power. Actually, power is measured in watts, which is W. And the instrument for measuring power is watt-meter. So watt-meter is derived from power. So when we are talking about power, we can say power is what? Power is a scalar quantity. It has magnitude, but no preferred direction. And this power has some other larger units in it. Number one, we have HP. HP is called horsepower. How do we generate horsepower? 1 horsepower is equivalent to 3/4 kilowatts, which is the same thing as 3/4 times 1,000 watts, because 1 kilowatt is about 1,000 watts. So by so doing, 3 times this should be around 3,000 watts over what? 4, and that gives us 750 watts. So therefore, 1 horsepower is equivalent to 750 watts. So by so doing, power in a real sense is the rate at which work is done, or we can say it is the energy expended per unit time, or it is the rate at which work is done per unit seconds. So power is subdivided into different segments. We have the real power, we have the apparent power, and we have the reactive power. So now, so when we are talking about power, we can say power has some other units, which is joule per seconds. How do we get joule per seconds? Joule per seconds is gotten from the formula, which is P equals work done over time taken. Where your work done is joules and the time taken is seconds, so P generally becomes Js raised to the power of -1 or J per seconds. So I would like to stop the class for today on work, energy, and power.
D-Tutors, bringing learning to your doorstep.